Let's have a look at this. So we're just going to talk quickly about arithmetic with complex numbers. That's what section 2 of module 3 is about. Really simple. Really simple. There's very little to this at all. I mean, there's really, all I want you to be able to do is add, subtract, multiply, divide complex numbers. So when we add up complex numbers, what do we do? What do we do with like the i's? Yeah, we just combine like terms. You just treat the I like a variable and you combine like terms for adding or subtracting. So complex numbers, remember, they have two parts. They have a real part. So in this case, if we take this complex number, 3 is the real part. What's the imaginary part? 2. Good. And so there's always going to be this real term and this imaginary term with complex numbers. Now, sometimes one of those could be 0. That's fine. But in each of these 4 cases, there's both a real part and an imaginary part. So a lot of times we'll put those in parentheses just so we can recognize that this is one complex number and this is one complex number. Do the parentheses around this first complex number really do anything? No, they don't. They don't because what number sits out in front of the quantity? A 1, and if I distribute a 1, it doesn't change a thing, right? So when I'm going through the process of adding these up, I would just probably eliminate the parentheses. You don't have to, but I think it's helpful. So we would just write this as 3 plus 2i plus another complex number. Well, if I'm adding something, it's the same as adding 1 times that quantity. So I can get rid of those also, right? So I'm just going to get 3 plus 2i plus negative 2 is really just minus 2, right? Plus 5i. So I was able to just get rid of those parentheses when I'm adding complex numbers. Don't even need them. Add up like terms, and what do we get? 3 minus 2 is 1. And then 2i plus 5i is? So that's our answer. Right there. That's it. No big deal, right? Okay, what about when I'm subtracting? There's only one small difference with subtracting. I can get rid of the first parentheses without doing a thing, right? Because there's nothing out in front. So we get negative 4 minus 3i. What do I have to do in the second case, though? Okay, good. I've got to distribute this negative 1, right? If I'm subtracting the quantity, it means I'm subtracting everything in the quantity. And so it's really the same thing as just distributing a negative 1. Distributing a negative sign is the same as multiplying everything by negative 1. So what am I going to get over here then? Minus 2. Good, because I'm distributing that to both parts. Minus 7i. And that gives me what when I combine like terms? What's the real part of my answer going to be? Negative 4 minus 2 going to give me negative 6. And the imaginary part? Yeah, negative 3i minus 7 more I is minus 10i. Okay, make sense? No big deal. Okay, multiplying is slightly harder, but just slightly. It's really not a big deal. If I multiply complex numbers, I'm going to start off with the very same process. In fact, it is the very same process as if those i's were x's. Now we're multiplying out these expressions. All right, I'm going to take the terms in the first factor and distribute those over the second factor. Right, so we'll take the 2 and we'll distribute that through. And what's that give us? 2 times negative 4 is negative 8. 2 times negative 5i would be negative 10i. Just treat the I like a variable. Okay, now the second step would be to take the other term in the first factor, the plus 3i, and distribute that. And what do we get? Positive 3i times negative 4 is? And then positive 3i times negative 5i is? Negative 15 I squared. Okay. Now, this is the one difference, and it's a minor one. I squared. Now, let's think about what's the definition of I? I is what? It's the imaginary unit, and the only reason that we ever invoke the imaginary unit is because we had a negative number under a radical, right? Let's put all our phones away, please. And let's put yours away, too. Okay, so I is equal to what? And what's it going to be? So if we had something, think why we use it. If we had something like the square root of negative 15, we would write that as the square root of 15 times I. So it's the square root of negative 1, right? It's just going to be that negative 15 is just negative 1 times 15, right? So that negative 1 comes out front, becomes the I, right? So I is just equal to the square root of negative 1. So then if that's the case, because that's the definition of I, it's the square root of negative 1, what's I squared equal to?
1.
Negative 1. Yeah. When I square a square root, I undo the radical, and so I squared equals negative 1. So every time you get an I squared, when you're doing arithmetic with imaginary numbers, what are you going to trade it for? Negative 1. And so if I trade that for a negative 1, really what's it do to that term then? Yeah, it just changes the sign of that term. That's all it ever does, right? So it's going to make that a plus 15. Okay, and that's what the I squared does. We can get rid of it, replace it with the negative that just changes the sign. So then what's my answer going to be if I combine like terms? Negative 8 plus 15 is what? 7. So that's the real part. So let's cancel those out as we go. So those two combine to give me 7. And then what about the imaginary part? Negative 10i minus 12i. Okay, make sense? So those guys combine. So all 4 of those just combine to those two terms when I combine like terms. Okay, only difference, I squared becomes negative 1. Okay. Dividing. Okay, dividing is there's a little bit more to it. With dividing, let's take an example real quick of what we do with square roots. What if I had something like, let's just say we had the square root of 12 fifths. Good review. What would we do to simplify that? Square root of 12 over the square root of 5. Good. So I can't reduce 12 fifths inside the radical, so I'm stuck with the 12 on the top and the 5 on the bottom. So we get square root of 12 over square root of 5. Can I simplify the bottom? I'm stuck with the square root of 5, right? What about the top?
Yes.
There is a perfect square factor of 12. What is it? 4. Good. So I can rewrite that as square root of 4 times square root of 3. And what is the square root of 4? So that's as far as I can go with just simplifying the radicals, but that's not my simplified answer. Because what's wrong with that answer? Okay, I can't have that. Something up there, say it again, something doesn't look right. Okay, well I can have 2, but I can't. Well, I guess you're right. You can't have 2 because you can't have 1 in the bottom, right? So we'd say we've got a stranded radical in the bottom. We got to get rid of it. What's our strategy for getting rid of a stranded radical in the bottom? Real simple. Say it again. Oh, right there. Go ahead. Say it again. Multiply top and bottom by whatever the stranded radical is. So it's a square root of 5. So I multiply top and bottom by the square root of 5. And the whole point of that is, what do I get when I multiply a radical by itself? What's it do? It cancels the radical, because it's squaring it, right? Same thing as squaring it. Squaring undoes square rooting. So I just get a 5 on the bottom. Now on the top, remember we're multiplying how many things together on the top? 3. We're multiplying 3 things. We can only multiply them in pairs, though. So which 2 should we multiply first? The radicals, yeah. And in fact, that's all we really can do. If I multiply the square root of 3 times the square root of 5, what do I get? Square root of 15, right? And then out front, I've got that 2. And I can't really do more than that, can I? 2/5 doesn't reduce, and there's no perfect square factor of 15. So that's our answer, right? Only reason I did that is because what we had to do is get rid of something on the bottom. We didn't change the answer, we just changed the form of the answer, so we didn't have a radical on the bottom, right? With dividing complex numbers, it's kind of the same thing. There's really nothing we could do to simplify the top or the bottom there, but we can't have a complex number on the bottom, right? We can't have an I on the bottom. So we've got to do something like what we just did. And it's going to be very similar. We're going to multiply the top and the bottom by something to get rid of the complex number on the bottom. Say it again? Okay, let's try that. If we multiply by negative 2i, that's a good idea. If we multiply top and bottom by negative 2i, something good, let's just focus on the bottom because that's where we got to get rid of the I, right? Something good happens there. The 2i times the 2i gives me a 2i squared, which is the I squared will go away. But the only problem with that is when I distribute the negative 2i to the 5, I'm going to get another I. So we're on the right track, but let's change slightly. Okay, multiply, say it again? By the whole bottom. Okay, let's try that. We're getting much closer. Let's see what happens if we do that. 5 minus 2i, top and bottom. Okay, so let's see what happens. If I multiply the 5 times, let's distribute. So the 5, when I distribute it to both parts, on the bottom gives me 25 minus 10i. When I distribute the negative 2i, I'm going to get minus 10i, and then I'm going to get what? Plus 4i squared, right? And the I squared is, that's fine, that just becomes a negative 1, right? So that's just going to make this a minus 4. Okay, almost worked. Almost worked. We got a negative 10i minus a 10i, which is a negative 20i. But what if somehow, what if we could have made the signs of those, call those the cross terms? Not that that's important, but the 10i, what if one of those could have been positive? Then it would have worked, right? How could I have done same thing, but just made one of those 10i's positive and the other negative? Yeah, what if I had flipped the sign there? What if that had been a plus, right? So now think what we're doing. We're multiplying by the same complex number, only we're changing the sign between the real part and the imaginary part. Okay, then how would that have changed things? Well, when I multiplied my original 5 through, I would have gotten 25, but then I would have gotten a plus 10i, right? And then when I distributed the negative 2i through, I would have gotten a negative 10i, but then I would have just gotten a negative 4i squared. So it would have changed the last term a little bit too. What's negative 4i squared? Plus 4. Right, because that's just a negative 1. Right? That worked, didn't it? Because now look what happens. The 10i and the negative 10i cancel, and I just get 25 plus 4 is 29. Right? Everybody see that? So it works on the bottom. We get a number, an integer, instead of an I. Right? We just get a real number only. Okay, what about the top? We have to do the same thing to the top. But that's okay. On the top, we can have i's, can't we? It's just that we can't have them on the bottom. So if I do the distribution on the top, 2 times 5 is 10. 2 times 2i is 4i. positive 3i, well, let's do that. Positive 3i times 5 is what? 3i times 5, 15i. And 3i times 2i is plus 6i squared, but that's just a negative 1, right? So what's that do? Just makes it a minus 6. Right, so then if we write all that, if we collect like terms, 10 minus 6 is 4, 4i plus 15i is 19i. And so that's our answer. Almost. It is the right answer, but on Moodle, I'm going to ask you to write these in standard form, which is what we always want to do. We want to write our answer in the form a plus bi. So how could I do that with that answer? How could I break it into a real part and an imaginary part? We call that 29 what kind of denominator? If we have one denominator on the bottom and a bunch of stuff on the top, what kind of denominator is it? Common? Right, because they're sharing the same denominator. But I can split that fraction apart, right? All that says is that the denominator is 29, and what we're adding on the top is 4 plus 19i. But I could just add two fractions with common denominators and get the same thing. Wouldn't you agree that I could say this? I could say that 2/3 plus 5/3 is the same as what? When I'm adding fractions up, I have to get a common denominator first, but I have a common denominator there, right? So when you're doing that, adding those fractions, wouldn't you just say, oh, okay, well, that's 2 plus 5 over 3, and then you'd get 7/3, right? Because you all would have told me 2/3 plus 5/3 is 7/3, right? So my point is just that, look right here, I can go either direction with this. I can either write this as a sum over one denominator, or I can split it into separate denominators, separate common denominators, right? So I could, if I wanted to then, take this answer right here, and I could just split it up into 4 over 29 plus 19 over 29 times I. And that looks like a plus bi, doesn't it? If I just split it into separate fractions. Okay? All right, let's do one more of those. That's messy. Let's try one more of those. I want to show you one thing though, quick. That trick we had about multiplying a complex number times the same number with opposite signs, connecting the a and the b. That's, by the way, that's called a complex conjugate. If I multiply complex conjugates, let's just take the general complex number a plus bi. What's its complex conjugate going to be then? What's the number? If that were on the bottom, what would I multiply top and bottom by? What did we do in that last example? We multiplied 5 minus 2i times 5 plus 2i. Right? That was the trick. So those were complex conjugates. What would I multiply this by to make the i's go away? Yeah, but okay, so right, the negative, the plus would become a minus, right? And it doesn't matter what order I write these in. I could have written the minus first and then I'd multiply by plus, right? But I got the same values of a and b, I'm just changing the sign, connecting them, right? If I do that, look what happens. If I distribute, I get a times a is a squared. A times negative bi is minus a times b times I. And then bi times a plus a times b times I. And then finally, bi times negative bi is minus bi squared. Well, look what happens. The middle terms will always cancel, won't they? Those are opposites. A times b times I and negative a times b times I. So those guys go away, and then the I squared is a negative 1. And so my result is always just going to be a squared plus b squared. every time. So you don't even have to, the reason I show you that is because you don't even have to go through the process of distributing everything. We could have saved ourselves a lot of work on this last one. We could have just said, okay, well, I've got 5 there and 2 there, and so my answer is going to be 5 squared plus 2 squared is 29, right? So for example, if I multiply out, you tell me what this is going to be. If I multiply out 2 plus, or we just did that one. What if we take 4 minus 7i? What's the conjugate of that? 4 plus 7i. And what's the answer going to be? What plus what? It's going to be a squared plus b squared, right? So it's going to be 4 squared plus 7 squared, which is what? 16 plus 49, which is 65, right? One more. Try this. I want to make a point here. So if we have negative 5 minus I, what's the conjugate of that? Negative 5 plus I. Okay, so what's my answer going to be? It's going to be what squared plus what squared? Okay, negative 5 squared, you're right. But what's negative 5 squared? 25. So here's a suggestion to you. Whenever you square a negative, what might you do instead? Like if I'm squaring negative 5, I know I'm going to get 25. So what could have made that a little easier? I could have just squared positive 5. Yeah. You know your answer is going to be positive, and you will, this is a really common way that people make simple mistakes, is that when you're squaring a negative, like on a calculator, you forget to put the negative sign inside parentheses. It's really easy to do. I do it. So whenever you square a negative number, just instead always just square the positive, and you get the same result. So I could write this, instead of negative 5 squared, just make it 5 squared, right? Then you don't have to worry about the signs. Plus what? 1 squared. Yeah, because what's the coefficient of I there? It's just negative 1 and positive 1. So we just get 25 plus 1 is 26, right? Does that make sense? Okay. So just do 1. If you can do this, you got this section is done, easy. So divide this one, or yeah, simplify this quotient. Okay, try that. Okay, so Everett, what am I going to multiply top and bottom by here?
2 and 3i.
Good. The conjugate of the bottom, right? Complex conjugate of the bottom. Okay, top's going to be some work, but what about the bottom? Emma, what number am I going to get on the bottom? I'm going to get what squared plus what squared? Remember, if I multiply a plus bi times a minus bi, I just get a squared plus b squared. And if you forget that, you can always just distribute. It's fine. But you can always depend on this shortcut too. When you're multiplying conjugates, it always works. So what do you think? I bet you'll get it. I bet if you can guess, you get it. It's going to be what squared plus what squared?
5 squared plus 7.
What's a? 2. Good. What's b? 3. So it's going to be a squared plus b squared. So What'd you tell me A was? 2 plus squared, yeah. That's it, that's the bottom. So the bottom is, what? What's 2 squared? 4. 3 squared? 4 plus 9? So the bottom's done, 13, that's easy, right? Top, we'd have to do a little work. If we distribute on the top, what are we gonna get here on the top? Let's see, Mallory, if I distribute the 3, what do I get? If I do this, what 2 terms do I get? 6 minus I. Good. Okay. All right. What if I distribute the negative 7i? What am I going to get with that, Cassidy? Negative 7i times 2. What's that going to give me? And then negative 7i times negative 3i is going to give me. So you get 21i squared, which becomes, what's I squared? So then that just becomes, right, negative 21. Good, so now we just combine like terms. 6 minus 21 is what? Negative, what, 15? And negative 9i minus 14i? Okay, good. So then, Ryan, how could I take that answer and write it in the form a plus bi? Okay, to both, just split the denominator up, so I get negative 15 13ths minus 23 13ths I. That's it. Okay. I can't reduce any of that. Okay, have at it. Grab a Chromebook. You can work for whatever time you got. And then tomorrow,